Ever wondered why Rapid PVST plus spanning tree protocol is a crucial part of modern networking systems? This question may seem complex, but the answer lies in the heart of effective network design. Rapid PVST plus, or per VLAN spanning tree plus, is like the maestro of an orchestra, coordinating network traffic to prevent loops and ensure smooth data flow. Imagine a city road network. Without traffic lights or signs, chaos would ensue. Rapid PVST Plus is the traffic controller of the networking world, managing data packets, preventing gridlocks, and reducing downtime. Its ability to create a loop-free topology for each VLAN increases network efficiency and stability. This protocol is not just a fancy tech term, it's a game changer, an essential tool in the arsenal of every network engineer. It's the backbone of healthy, resilient, and efficient networks. So, are you ready to dive into the world of Rapid PVST Plus? Stay tuned as we delve deeper into the workings of this ingenious protocol. To truly appreciate the marvel that is Rapid PVST Plus, we must first understand its foundational principles. Diving in, Rapid PVST Plus, or Rapid per VLAN Spanning Tree Plus, is a network protocol engineered by Cisco. It's a derivative of the Spanning Tree Protocol, STP, that provides a separate spanning tree for each VLAN, enhancing network efficiency. A critical component of Rapid PVST Plus is the Bridge Protocol Data Units, commonly known as BPDUs. These are data messages exchanged across switches within an extended LN that contain information on bridge IDs and route path costs. BPDUs are essential as they determine the network's topology and help in making vital decisions such as choosing the route bridge. And speaking of the route bridge, it's another fundamental aspect of Rapid PVST Plus. The route bridge serves as the reference point in the network and all data flow is organized around it. So, how is the route bridge elected? It's quite simple really. The bridge with the lowest bridge ID is elected as the route bridge. The bridge ID is a combination of a priority number and a MAC address. By default, all switches have the same priority, so the one with the lowest MAC address becomes the route bridge. However, network engineers can manipulate this process. They can set the priority of a switch to a lower value to ensure it gets elected as the route bridge. This ability to influence the election process is a significant advantage as it allows engineers to optimize network performance by strategically positioning the route bridge. In essence, Rapid PVST Plus is a smart, flexible protocol that enhances network efficiency by allowing a separate spanning tree for each VLAN. It uses BPDUs to map out the network topology and elects the route bridge based on the lowest bridge ID, a process that network engineers can influence to optimize performance. Now that we have the basics down, let's tackle the operations of Rapid PVST Plus. Rapid PVST Plus isn't just a fancy name, it's a protocol that performs some complex operations. Now, let's delve into the nitty-gritty of these operations. Rapid per VLAN Spanning Tree Plus, or Rapid PVST Plus, is a Cisco enhancement of the standard spanning tree protocol designed to optimize network performance. The operations of Rapid PVST Plus can be broken down into a few key steps. First off, Rapid PVST Plus operates by establishing a route bridge. This is essentially the epicenter of the network, from which all path calculations are made. The bridge with the lowest bridge ID, BID, is elected as the route bridge, with the BID being a combination of the bridge's priority and its MAC address. Once the route bridge is determined, the next step is to calculate the shortest path to the route bridge from all other network bridges. This is done using the path cost, which is a numerical value assigned to every network path based on its bandwidth. After the shortest paths are established, these become the route ports for each non-route bridge. But Rapid PVST Plus doesn't stop there. It also identifies designated ports, which are the ports with the shortest path to the route bridge on every network segment. Now you might be wondering what happens with the remaining ports. Well, these ports are placed in a blocking state to prevent loops, ensuring a loop-free topology. Rapid PVST Plus also incorporates the use of Bridge Protocol Data Units, or BPDUs. These are packets of information that are sent out every 2 seconds to maintain the network topology and detect any changes. If a change is detected, Rapid PVST Plus swiftly reconfigures the network to maintain its efficiency and loop-free state. And finally, Rapid PVST Plus utilizes a feature known as port fast for edge ports that are connected to a single device, drastically reducing the time it takes for the port to transition from blocking to forwarding state. With the operations clear, it's time to compare Rapid PVST Plus with other protocols. With this understanding of Rapid PVST Plus operations, we can better appreciate its impact on network performance and stability. In the world of networking, there are many protocols, but what sets Rapid PVST Plus apart? Let's dive right into it. Rapid PVST Plus is a Cisco proprietary protocol that provides for fast convergence of the spanning tree protocol. It's a unique protocol that has a few tricks up its sleeve. Unlike traditional spanning tree protocol (STP), Rapid PVST Plus provides a separate spanning tree for each VLAN, which allows for load balancing and optimizes network performance. Now let's compare it with some other protocols. Take multiple spanning tree protocol, MSTP for instance. MSTP also allows multiple VLANs to be mapped to a single spanning tree, reducing the CPU cycles for each switch. But here's where Rapid PVST Plus takes the lead. It offers faster convergence times, which can be a game changer in a dynamic network environment. When we compare Rapid PVST Plus with Common Spanning Tree Protocol, CSTP, the advantages are even more pronounced. CSTP uses a single spanning tree for all VLANs, which can lead to suboptimal use of network links. Rapid PVST Plus, on the other hand, optimizes the use of network resources by allowing for multiple active paths. What about Per VLAN Spanning Tree Protocol, PVST? Well, Rapid PVST Plus is essentially an enhanced version of PVST. It incorporates the fast convergence time of Rapid Spanning Tree Protocol, RSTP, giving it an edge over PVST. And let's not forget the simplicity factor. Rapid PVST Plus is relatively easy to configure and manage, an aspect that certainly adds to its appeal. In the grand scheme of things, the choice of protocol in network design often boils down to specific requirements and constraints. But Rapid PVST Plus often comes out on top. It's a robust and versatile protocol that offers fast convergence, load balancing, and optimal resource utilization. So, when you're designing a network and weighing your options, remember that Rapid PVST Plus might just be the ace up your sleeve. It's a protocol that's designed to adapt, to optimize, and to perform. As we can see, Rapid PVST Plus holds its own amidst numerous protocols. Now, let's shift gears a bit and focus on another key area: Cisco wireless architectures and AP modes. In the world of networking, Cisco wireless architectures and access point or AP modes play a pivotal role in shaping the structure and functionality of a wireless network. They provide the backbone for wireless connectivity, enabling seamless communication and data transfer across the network. Let's start with Cisco wireless architectures. They are essentially the blueprints for constructing a wireless network. There are 3 key architectures you should be familiar with. The first is the autonomous or standalone architecture, where each AP operates independently from others. This is ideal for small networks, where centralized control is not required. The second is the controller-based or lightweight architecture, where APs are managed centrally by a wireless LAN controller. This offers easier management and advanced features, making it suitable for larger networks. The third is the cloud-based or Meraki architecture, which uses cloud services for centralized management. This offers flexibility and scalability, making it ideal for businesses that need to quickly adapt to changing needs. Now, let's talk about AP modes. These determine how an access point operates within the network. There are 5 main modes to be aware of. The local mode is the default and allows the AP to serve clients. The Flex Connect mode, previously known as HREAP, allows APs to switch client data traffic locally and perform client authentication locally when their connection to the controller is lost. The monitor mode allows APs to monitor their surrounding environment for malicious activities or for troubleshooting. The rogue detector mode enables APs to detect rogue APs. Lastly, the sniffer mode allows APs to capture and forward all the packets on a particular channel to a remote machine. Understanding these concepts adds another layer to our networking knowledge. As we delve deeper into the world of networking, these foundational ideas will guide us in building and managing effective wireless networks. By mastering these, you'll be well on your way to becoming a network engineer par excellence. Understanding these concepts adds another layer to our networking knowledge. So, we've covered a lot of ground today on Rapid PVST Plus and Cisco wireless architectures. In this episode, we delve deep into the mechanisms of Rapid PVST Plus, understanding its need and basic operations. We discovered how it stands out from other protocols, providing efficient network solutions. It's crucial to comprehend these subtleties to effectively manage network traffic and prevent looping. We also took a journey through the realm of Cisco wireless architectures and access point modes. From understanding their comparative advantages to exploring their intricate functionalities, we've seen how these aspects shape the backbone of wireless networking. Remember, in the world of network engineering, knowledge of protocols and concepts alone doesn't suffice. The real skill lies in leveraging them to optimize network performance and mitigate potential issues. With that, we wrap up our discussion on Rapid PVST Plus. Remember, a good network engineer not only knows the protocols but also understands how to use them effectively.